I'm Shannon Zimmerman, and welcome to Science and Engineering Practice Number 1, Asking Questions and Defining Problems in the NGSS. In this video, I'm going to walk you through the components and requirements that you're going to need to go through for the Level 1 part of the badge.
Okay, teacher friends, here are the Level 1 objectives. You're going to understand SEP number 1, which is asking questions and defining problems. You're going to explore some teaching tools that the students or you will use with the students during the questioning strategy, and then understand that questioning strategy and some tools that go along with that. So let's get started with understanding the SEP. Okay, so here are some tools that you can use to help you better understand the SEPs in the NGSS. So the first one I want to point out to you is this NGSS SEP matrix. Click here and you're going to find a breakdown of the Science and Engineering Practice 1 by grade level. So what they should know in K2, 3, 5, middle school, and high school. So make sure that you're looking and being aware of what the expectations are for your students in terms of asking questions and defining problems. The next 3 are videos that go into how to do that and what it means in the NGSS. They're all put on by the Wonder of Science, which is created by a man named Paul Anderson, also known as the Bose Man. He does a fabulous job of really simplifying how the standards come together in the different dimensions. And he is one of my go-to resources. I think he does a really good job and makes it easy to understand. So watch those 3 videos. Once you have a better understanding of the SEP1, you're going to start looking at tools to be able to deliver that with your students. So some of these tools are to be done independent, some are whole group. You can figure out how you want to scaffold those and teach your students. You may want to start with something and do it whole group just to teach them how to use the tool and eventually wean them off to be able to ask questions on their own. I've categorized these into 3 different types. There's the digital questioning tools, Padlet, Jamboard, and this is a Google Doc I created. So those will, if you choose one of these, we'll have some additional videos to help you understand how to use those digital platforms. And then next we have some whole group and independent tools. The Wonderwall I want to talk about, this is a Google Slides that just give ideas on how you can do this whole group, whether it's on a whiteboard, a chart paper, or if you put up a board somewhere in your room to have them go through the questioning strategies. These other 2 are inquiry cards made by the Wonder of Science, and we're going to talk about those in more depth in just a few minutes. Last, we have some graphic organizers. They include a clue chart, I notice, I wonder, what do I wonder, and an asking questions graphic organizer that you'll recognize from one of the videos you watched earlier. So go through those different tools, get a feel for what you might use with your class. You're going to pick out at least 2 of those that you want to try. You want to try either by yourself or with your kids. So now let's move to the strategy. So before the lesson, you're going to want to choose a standard, an NGSS standard that has SCP-1 as one of the practices attached to it. Once you've done that, identified that standard, you're going to find a phenomenon that gets the kids wondering. This is going to be in the engagement piece. How do you engage the kids into thinking about this phenomenon that's going to lead back to that standard? And here we have the process. So it's brainstorm, classify, improve. That's your basic process to use for any of the tools. So having those kids brainstorm their questions, you want them to at least put down 8 questions. You might want to start them with a question if they're having a hard time, have them ask some questions, and maybe even do some follow-up questions like you saw in the video. Next, the kids are going to classify the questions. Organize them by these 4 categories: observational, explanatory, systems, or engineering. The cards are going to help you, and I'll show you how that works in a minute, but they're going to be organized according to the cross-cutting concepts. This is the way they should be thinking about what they're doing. So then they're going to improve their questions. So, improving the questions is probably the most critical skill because we need to get them to improve these questions to be able to be tested. And not only tested simply, but it has to be empirically tested, which means it's going to be firsthand observation or firsthand experience. So, these are not questions that you can go find the answer to Google on. It's something that they can do in the classroom with the materials and tools that they have available to them. All right, so let's look at the cards. Okay, so our inquiry cards are categorized into three different colors. So the orange cards are related to the disciplinary core idea. That's the content, that's what they need to know. If they are doing a science inquiry, you're going to be choosing a phenomenon that's based on something they're wondering about in the natural world that they can then go on and inquire about. If you present them with the phenomenon that is problem based or present them with a problem, then that will lead them to an engineering design challenge. And then next, you look at the blue cards. The blue cards are the science and engineering practice cards. That's what the kids should be doing. And you can see that they have put the process down here. They're going to brainstorm questions, they're going to classify questions, then they're going to improve their questions. And here are some things to help them come up with good questions. They should be based on a phenomenon or problem. They should identify the nature of the question. And this is where we get four different classifications: observational, explanatory, systems, and engineering. And then can those questions be empirically tested? That's like, how do you improve those questions? So, with that, we're going to move on to the green cards, which are your cross cutting concept cards. This is how the kids should be thinking as they're doing. Okay, so how are they thinking? If they've asked questions about something they observed, what are they noticing? Most likely those questions are going to be based around patterns. So you're going to see here, what do I notice, classified as observational, and you'll see that question up here, what do you notice? It's going to make it a little easier to put the connections through and classifying those cards according to cross-cutting concept. Now, once they classify all the questions, you can use these cards, these cross-cutting concept cards, flip them over, and you're going to get more probes for the students. So patterns of what they see, hear, touch, smell, or taste. Is it structural properties, relationships, or times? And then some more probing questions down here to help them improve their questions. So I want to show you the backside of all of the cross-cutting concept cards and talk about the front as well on improving questions. So we have a patterns card, a cause and effect, and a system and system models. Let me move this over. Patterns is the cross-cutting concept all by itself. So you're not going to see any other cross-cutting concepts within this. But if you look at cause and effect, you're going to see the structure and function cross-cutting concept embedded in that. And on the back side of the card, how does it work? How does it work in terms of cause and effect? How does it work in terms of structure and function? And then there's some probes and some visuals for them to think about. And the same thing with systems and systems models. Is it a system of energy and matter, scale, proportion, and quantity, or stability and change? And then those probing questions that can relate to each one of those. All right, hopefully those cards will help you put those three dimensions together. Remember, it's what do they need to know for the orange? What are they supposed to be doing in the blue? And how should they be thinking about it is the green. All right, your final step for level 1 is the assessment. So you guys are going to go to Google Classroom. There's a Google form in there that you can complete an assessment. It's going to be check for understanding, but it's also going to be some opinion questions like what were your favorite tools that you might use with your students. Hopefully this helps, and good luck on asking fabulous questions.